Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to the first lesson in a new unit about sequences and series. In this unit, we will revise our notions of sets and functions and learn the concept of sequence and series. We will compute the terms of sequences from given rules, derive formulas, and identify different types of sequences and series. We will even compute infinite sums of sequences and learn to apply our knowledge to real-life problems. We have much to learn in this unit, students. Let us get started right away. Number sequences are helpful in making predictions about events. In some number sequences, we will see that it is possible for the sum of an infinite number of non-zero numbers to be finite. This concept plays a central role in many sciences and has important applications. First, we must revise what we have already learned about sequences. The word sequence, when used in conversation, means a list of things that occur in a specific order. In mathematics, a sequence is viewed as a set of numbers that come one after another according to a given rule. For example, consider the following problem. Aster's monthly electricity bill is 80 birr, and she must pay it at the end of each month. If she does not pay it, the amount will increase by 5 birr a day. What will Aster's bill be after a delay of 6 days? How about 15 days? How about a number of days represented by n? Try to solve this problem now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. The amount to be paid after n days forms this pattern in bir: 85, 90, 95, and so on to 80 plus 5n. Therefore, after 6 days, her bill would be 110 bir. After 15 days, her bill would be 155 bir. After n days, her bill would be 80 plus 5n. Clearly, Aster should remember to pay her bills on time. This activity has showed us a simple example of a number sequence, students. A sequence is a function whose domain is the set of positive integers or a subset of consecutive positive integers starting with 1. These are called the terms of a sequence. This is the general term, or the nth term of the sequence. The sequence A1, A2, A3, and so on through AN is also denoted by the set of AN or the set of AN exponent infinity. Sequences can be described by listing their terms, writing the general term, drawing a graph, or using a recurrence relation. Let us examine each of these steps individually. We can list the terms of a sequence by associating each positive integer with its reciprocal. We thereby obtain a sequence denoted by the set 1 over n, which represents the numbers 1, 1 over 2, 1 over 3, 1 over 4, and so on to 1 over n. To write a formula for the general term of a sequence, we must examine the terms to find a pattern. Some patterns may have more than one correct formula. It is time for another activity, students. Write a general term for each of the following sequences.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Sequence A was very easy to write a term for, was it not? It is increasing integers cubed. Therefore, we may write the general term as an equals n cubed. Sequence B is not quite as simple. It is the result of multiplying n by 2, adding 3, and dividing the sum by 2. Therefore, we may write the general term as an equals 2n plus 3 over 2. You probably found sequence C to be the most tricky. It is the result of multiplying n over 2 by n plus 4. The general term is therefore an equals n over 2 times n plus 4. As we have learned, sequences can also be expressed graphically. The graph of sequence C, for example, looks like this. The y-axis is marked as an, and the x-axis is marked as n. In this way, we can express the general form of the sequence without having to plot an infinite number of values. A recurrence relation is a bit different. It is an equation that recursively defines a sequence. Each term of the sequence is defined as a function of the preceding terms. The Fibonacci sequence is a recurrence relation. For our last activity, calculate the sequence described by the first 15 terms.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
How did you do, students? The Fibonacci sequence begins this way: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and 377. You see that each result depends on the result that comes before it. This is called a recursion formula. The sequence is constructed by choosing the first two numbers called the seed values. Then we assign the rest by the rule that each number be the sum of the two preceding numbers. For example, if we take our seed values to be 4 and 7, the sequence would go 4, 7, 11, 18, 29, 47, and so on. The Fibonacci sequence is very useful in real life. It is used in financial analysis, computer algorithms, and data structure. It also appears in nature, such as the breeding of rabbits, the branches of trees, and the arrangement of pine cones. That is all for today. Until next lesson, thank you, teacher. Thank you, students.